In 7.1, we're learning about random variables. Earlier this semester, we learned that univariate data can be either categorical or numerical. In Chapter 7, we're focusing on numerical variables. And so those can be split up into two categories. The first one is discrete. So imagine you have a number line that contains reasonable values. If the variable is discrete, then it can only fall at certain isolated points along that number line. It cannot fall in between those values. And typically, the way you find the value of a discrete variable is by counting. All right. Now, sometimes there are variables that can fall anywhere on this number line within reason. So anywhere in a reasonable range. It's obviously not going to be infinite. So those types of variables are called continuous. And usually these are found by measuring. Right, we have 5 examples. So the number of broken eggs, that is discrete. There are only 12 eggs in the carton, and the number of them that are broken has to be a whole number. Right, amount of ozone, that is continuous because I'm guessing that can increase by a very slight amount. So the biggest clue that something is continuous is if it can be a really long decimal. Right, so the weight of a pineapple, that does not have to be an exact integer number of ounces. It could be in between. You could have a string of decimals afterwards. So that's continuous. The amount of time someone spends in the store, that is also continuous. They could stay in the store an extra tenth of a second, an extra 0.347 seconds. And then the number of gas pumps in use, that is discrete. That is found by counting, and it must be a whole number. In 7.2, we're learning about probability distributions for discrete random variables. We will learn probability distributions for continuous variables in the future. All right, so what a probability distribution is, it's a table or a graph or an equation that shows the probability associated with every single possible value of x. We learned last chapter that one way probability is determined is just by looking at the recent history or many trials and seeing how often something occurs, and then using that data to estimate the probability. All right, so in our first example, there is a city where you are not allowed to have more than 5 dogs or cats. X is the number of dogs or cats that a randomly selected household has. And so X is obviously discrete because the number of dogs or cats must be a whole number. Right, the possible values of X are 0, 1, 2, 3, 4, and 5. We stop at 5 because that's the limit for this city. Right, and now we have 2 examples of probability distributions. There's a table showing every single value of X and the probability associated with it. And then those values are shown below in a histogram. All right, so we have 3 questions to answer below. All right, so I want to show a little bit of probability notation They want to know the probability that if we select a household at random, there are at most 2 pets. So at most means we want x to be less than or equal to 2. All right, so on the AP test, if you only write the answer, you do not get full credit, even though the question does not ask you to show your work. So you need to show your work. The way we figure out the probability that the house has less than or equal to 2 pets, we go to the table. And so the values that satisfy less than or equal to 2 are 0, 1, and 2. And so we have to add up the probabilities for each of those. So 0.26 plus 0.31 plus 0.21 equals 0.78. All right, and then the second question is asking the probability that x is strictly less than 2. All right, so the only difference is this does not include 2. So we're going to add up 0.26 and 0.31 only, and we get 0.57. All right, so the key thing I want you guys to take away from this is that when you include 2, notice it makes a big difference in the final answer. And that will only happen for discrete data. So including 2 versus not including 2 makes a big difference. When we get to continuous data, these 2 questions would have the same answer. And the reason is, with continuous data, you could possibly have many decimals. And so including 2 versus not including 2 is basically only including 2.0000. It's only including 2 measured to a very precise amount. And the probability that whatever x is going to equal exactly 2.000, the probability of that is basically nothing. So including that versus not including that doesn't really make a difference. All right, and there's one more question. They want the probability that, all right, so this one, x is going to be between 2 values, more than 1, right? So that means x is not allowed to equal 1, but not more than 4. So x is allowed to equal 4 because not more than means less than or equal. All right, so for this one, we want to add the probability of 2, the probability of 3, and the probability of 4. So the probability of 2 was 0.21. The probability of x being 3 was 0.13. And the probability of x being 4 was 0.06. So we get the answer is 0.4.